Okay, what we are going to be going through today is section 2.3, where we're going to learn how to do a few other types of graphs. We're going to be working on the secant and cosecant graph, and then we'll be moving on to the cotangent tangent graph in section 2.3, or 2.4 rather. Okay, so 2.3, we're going to be looking at these two things. To begin with, let's go over a little bit of calculator usage. So you don't have a secant button on your calculator, but what you do know is you know that the secant is equal to 1 over the cosine. Okay, so we know that this would be the same as 1 over the cosine of 4.2. So we're going to put this in the calculator like this. We're going to go 1 over cosine of 4.2. Now this is in radians. So the first thing you want to do is make sure that you're in radian mode. If you aren't, put yourself in radian mode. Highlight radians, press enter. Okay. Now just go like this on your calculator. Go 1 divided by cosine of 0.42. Okay. So if we do that and round that off to 4 decimals, we will end up getting, for an answer, 1.0952. Okay, next problem you do the same thing. You say 1 over cosine 2.94. Again, being in radians. Okay, so we do that. Round off to 4 decimal places. You're going to get a negative this time because of the quadrant you're in. You're actually in quadrant 2. And the cosine and secant are negative in quadrant 2. That's why. So this is negative 1.0207. Okay, then the next one is dealing with the secant. So we're going to do 1 divided by the sine of 3.66. Again, that's in radians. So we want to go ahead and do that. Okay, so that will give, again, a negative answer. And the reason for this is quadrant 3. Okay, the thing is, pi is 180. This is a little bigger than pi because it's over 3.14. And the sine is and cosecant are negative. So it's always a good idea if you get a negative on your calculator to know why. Okay, based on what you've learned about the trig functions. Okay, so I'm going to go ahead and just very briefly have you pause and put the next two in, see if you get those right, then we'll move on to the Okay, so here's what you should have did on these problems. Okay, this problem you should have done 1 over cosine 0.31. So if you put that in, we are going to get a positive answer because we're in a quadrant 1 angle situation here. So that is 1.0500, or actually 01, because of the 5 on the end of that if we round that to 4 decimals then. Okay, and then the next one you'll put in a similar way. You'll put the next one in as 1 over the sine of 5.24. This is probably going to give you a negative answer because of the quadrant you're in. You're past pi, you're past 180, and you're not all the way to 2 pi, so you're in quadrant 4, I think, on this one. So if you go 1 divided by 5.24, might help if I do the sine. 1 divided by sine 5.24, you're going to get a negative answer. So that will be, when we round that, that's going to be negative 1.1574, like that. Okay. Now, if you did this, if you did 5.24 times 180 over pi, just reminding of how to convert radians to degrees, so you get 300 degrees. So that's a quadrant 4 angle. So you ended up having a negative answer because the sine and cosecant are both negative in quadrant 4. Okay, so the next thing we're going to look at is we're going to look at filling the table of values out for the cosecant. And then on the next page, we'll construct a graph on this now. Okay, so as we go through this, we're just going to use the unit circle. The hope is by now you have memorized what these values are in a unit circle. So we'd have, going around the unit circle, the sine again is the y value. So I'm going to just highlight all these y values. and then we're going to go through and fill out our table of values. Now I'm going to do the basic sign in red. So we know the sine of 0 radians is 0. The sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is negative 1. And the sine of 2 pi is going to be 0. And by a similar argument, the sine of negative 2 pi, of course, negative 2 pi is clockwise around the circle. Negative 3 pi over 2, again, is clockwise, so that's 1. Negative pi goes like that, so that's 0. And then negative pi over 2 goes like this, so that's negative 1. So it takes us through 2 periods of that. Now, what we're going to do that's different this time is we're going to work out the secant. So what we're doing on this is we know that the cosecant, by its definition, is 1 over the sine of x, or you can think of it as r over y. So in this particular thing, what we're going to have is just take the reciprocal of sine. So notice at negative 2 pi, we have 1 over 0. So that means the function is undefined. Then if we go to the next one, we have 1 over 1, which is 1. 1 over 0, again, is undefined. 1 over negative 1 is negative 1. 1 over 0 is undefined. 1 over 1 is 1. 1 over 0 is undefined. 1 over negative 1 is negative 1. And then we have another undefined like that. Okay, so that's how that's going to go then. Okay. All right, so let's move to the next page. And what we're going to do on the next page then is we're going to begin to look at how this graph is going to go. All right. So basically, here's kind of what you have on this. We're going to go ahead and we're going to construct a sine wave on this first of all. So let's go ahead and get our axes put together here. So we're going to go by increments of pi over 2. So we got pi over 2, pi, 3 pi over 2, and then we're going to go all the way out to 2 pi, so that'll cycle us through 1 period. And we'll go ahead and do the negatives. So you want to go ahead and get that set up like this. Then when you do the y values, we want to go like this. We want to go up to maybe about 4 or 5. I'm just going to maybe go up to 4 and do the same thing with the negative numbers. Go down on the y-axis with the negatives. Like this, then we're going to construct our 2 graphs. Okay, now, again, the hope by now is that you would just know the sine graph and how that goes. So we're going to go ahead and graph y equals sine x, and I'm going to graph that in a dashed line. Okay, so sine starts at 0, 0. So that's going to just sort of cycle through these points like we did on the table of values. So we want to go ahead and just get those plotted. And then we'll sketch this in a dashed line to represent 2 periods of this sine wave. Okay, so we want to go ahead and get that done. All right. Now, when we go through and do the graph of the cotangent, the first thing we want to do is every place where the cosecant, everywhere the cosecant was undefined, what we're going to have is we're going to have vertical asymptotes. So you want to go ahead and all of these places where you have what we call midpoints. These are midpoints. These are going to be the places where the cosecant is going to be undefined. So what you want to go ahead and do is get those asymptotes put in together. Then the rest of it, I'll teach you how to just sketch in, and then I'll show you on the calculator why that is, why the graph does the way it does. Okay, so that's what you do. When you graph a cosecant, you want to start like that. Now what I'm going to do on this then is I'm going to go ahead and I'll just choose another pretty color. And then I'll do this in a solid line, so I'll do y equals cosecant of x, okay? So what it does is, a lot of times I think of this as kind of like a camel's back. So what you do is you make the cosecant, just turns out that what it does is it sort of sets on top of the camel's back. It has this sort of U-looking shape, and it approaches the asymptotes. Now, it's never going to touch those asymptotes, but it's going to almost kiss them. I always tell students, I one time saw a t-shirt that says, "Kiss my asymptote." There's my stupid math joke for the day. Okay, so the point on that, though, is it helps students remember that when you're dealing with vertical asymptotes, it doesn't touch it, it just approaches. So it gets kind of infinitely close to it, but never comes in contact with it, okay? So it's kind of a boring kiss, I guess. All right, so that goes like this. That goes like that. And so forth. So that would actually take you through 2 periods of the cosecant wave. So one of the things you're going to find is that right there would be a period, and then this would be the second period like that. So you can kind of think of basically the period being from 0 to 2 pi, so that period is going to be 2 pi. Okay, let me show you a couple of things on the graph of this now, on the graphing calculator, and just kind of give you an idea why this happens. So since the cosecant's 1 over sine, let me show you what happens if you were barely to the right of 0 radians. So what I'm going to do is I'm going to go 1 divided by sine, and I'm going to pick a number that's just, real close to 0 that's bigger than 0. So notice you get an answer of 100. So you're going way, way up there. And then if I picked a number like 1 divided by sine of something even smaller, closing in like that, okay, well, it gets bigger and bigger. So theoretically, as we put more and more zeros in this like that, notice that that value just gets infinitely big like that. And then if we went to the left of that, just barely to the left of 0, and if we did like 1 divided by sine of a very small negative number, or actually just a negative number that's very close to 0, then notice what happens is we get a very small negative number, so that's why that closes in like that. So again, the closer you get to 0 on the left side of the y-axis, the lower down the graph gets. So it's kind of helpful to understand why that mathematics works the way it does. Okay, now what we're going to do is do a few observations of this. So now the domain on this is a little interesting on this. Basically, if you look at, and I'm going to highlight these areas where you have asymptotes, because these are the places where this cosecant wave is undefined. Okay, so we need to go ahead and do this and get those things labeled now. Okay, so what we have on this is, let's just list these things out. So we have like negative 2 pi, we have negative 1 pi, I'm going to write this as 0 pi, 1 pi, 2 pi, and etc. Okay, so what you're going to find is these asymptotes, of course they go on infinitely like this, and then the next one would be 3 pi, and 4 pi, and then forever. Okay, so we have an infinite number of places where the cosecant's undefined. So what we have to do is, instead of listing them, we have to write a formula. So what we generally are going to say on this is we're going to say the domain is the set of x, and then we're going to say such that x is not equal to. Now, instead of just listing them out, we have to generate a formula. So the idea is, think about the kind of numbers that are the coefficients of the pi. Those are what we call integers. 1, 2, 3, 4, etc., -1, -2, and so forth. Those are all called integers. So what we say on this is basically integers, again, are an infinite set of numbers that goes like this. It would go ... like -2, -1, 0, 1, 2, ... So what we say is we say k pi. Now see, this k is going to represent all of these integers. So we say k pi, then we say k is an integer. Now in mathematical symbols, if you want to learn to do this, you can say k is an element of the integers. So you'll see that this symbol right here is a set element. It just means that it's an element of, or it's a member of, this set of integers. And then this kind of funky looking z is a symbol that we use for integers. Okay, so that would be how you'd write the domain on that. Okay. Now, if you look at the minimum, see this cosecant gets infinitely low, so we don't have a minimum value. We also don't have a maximum value because it gets infinitely high. So that's also none. Okay. And then the range. Now the range on this is, notice that there's a little gap. Wherever the sine wave is, the cosecant does not have y values. So it would really be written in one of two ways. One way you could write this range is you could say set of y, and then you're greater than or equal to the y value of 1c. So you could say that, and then you're also less than negative 1. Okay, but between negative 1 and 1 on the y-axis, you don't have a cosecant graph there. So you just say set of y such that y is less than or equal to negative 1, or y is greater than or equal to 1. Or in interval notation, you would say negative infinity to negative 1 bracket, and then union 1 to infinity, like that. Okay. All right, now the period is 2 pi. Okay, that again is the width of this shape. So if you go from 0 to 2 pi, you cycle through these things. So think of a period as one of the U-shapes pointing up, one of the U-shapes pointing down. So the period is always like this. You have an asymptote, you have an up U-shape, another asymptote, a down U-shape, and the ending asymptote. So that's how that period goes on this. Okay. Now, as far as the amplitude goes, you actually don't have one. And the reason is because you don't have a minimum and you don't have a max. And the amplitude is defined to be this. It's basically 1/2 the distance between the max and min. Since we don't have a max and min, we're never going to get a numeric value of that. Okay, so that's how that goes. And then the asymptotes go like this. Well, the asymptotes are always named by x values. So you actually have an infinite number of these things. So you would have like x equals, but if you look at the pattern we had up here, those are where your asymptotes exist. So we just have to say x equals k pi. And then again, we say k is a member of the integers, like that. So that's how you got to put the asymptotes together, is you have to state them. Okay. All right. Now we're going to move on. We're going to look at the secant graph, and the secant graph is fairly similar in regard. So I'm going to go around, remember, on a unit circle. The secant is going to be defined by the x value, actually. So we're going to go ahead and do the cosine first of all. So we're going to go ahead and go around the unit circle and get this. Now, a couple of things that I see that I have a mistake on here that I need to correct for a minute here, is this. So this was supposed to be the cosine, I believe, cosine of x. So we need to go ahead and scratch that thing out and do that. So let me get this corrected here on this and just kind of scratch all that out. So this, you need to change that to the cosine and the secant, like that, because we're going to graph the secant. So the key thing on this is we need to have those things put together and corrected then. Okay, so let's go ahead and get that corrected, and then we'll begin to do a graph on this. Okay, so the first thing I'm going to do is we're going to do the cosine of x. So let's go ahead and go to the unit circle and get that put together. Okay, so the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Like that. Cosine of 3 pi over 2 is going to be 0. And the cosine of 2 pi is going to be 1, like that. And by the same argument, if you go -2 pi, that's clockwise, so that takes you to 1. 3 pi over 2, -3 pi over 2 is clockwise, that's 0. Negative pi, again clockwise, that's -1. And then negative pi over 2 would give you a x value of 0, like that. Okay, now what we know is the connection again, between the cosine and secant is the secant of x is equal to 1 over the cosine of x. Okay, so what we're going to do when we do this secant graph is we're going to go through and do reciprocals. So we do 1 over 1, that'll give us 1. 1 over 0 is going to be undefined, so the secant is undefined at negative 3 pi over 2. Then we do 1 over negative 1 here, that's negative 1. 1 over 0 is undefined. 1 over 1 is 1, 1 over 0 is undefined. 1 over negative 1 is negative 1, and so forth. Okay, so that's how you crunch out a secant, is you do that. Okay, so that's the key thing. Now this graph of this secant is going to be very similar to the graph of the sine, okay, of the cosecant. All right, now I'm going to continue to the next page here. And as we go to the next page, we're going to go ahead and put together our graph then. Okay, and again, the intention by now is that you have the cosine wave memorized. It'll allow you to do these graphs faster. So let's go ahead and just start setting up your x and y axis. Okay, and it's important that you always label these things the way I'm doing there. Don't be lazy about that. Then we should be able to get this thing all put together then. What in the world am I doing? Okay, see how sloppy and messy I'm being here? Come on. All right, let's get that better. All right, I know better than that. This is negative pi, and then this is negative 3 pi over 2, and then this is negative 2 pi. Okay, now let's make the y-axis go up to maybe 4, and maybe down to negative 4 like that. Okay, so what we're going to do is this. We're going to go through and we're going to go ahead in red and we're going to graph y equals cosine of x. Okay, just taking the key points from the unit circle. So the one thing to remember is the cosine starts high. So we're going to go there, then we're going to go to what we call the midpoint, then the minimum, back to a midpoint, and back to the maximum, like that. Now that cycles through one period of the cosine wave, like that. Okay, and then the same thing here, that goes to midpoint, minimum, midpoint, maximum, like that through another cycle, and then we'll get that sketched in like that. Okay, so anytime that you graph the secant, or the secant, yeah, you want to graph the cosine to do that. Now what we do next is we identify our asymptotes. So the asymptotes are going to occur at all these midpoints. So you want to go ahead and put dashed lines, vertical dashed lines through the midpoints. Those are the places where the secant is undefined, because you're really doing the reciprocal of 0. So that's why. So we'll have several asymptotes, as we're going to be doing a graph of this through 2 periods. And then the rest of this is very similar. We just go through and we sketch out the shape, and then we're done. Okay. So I'll go ahead and take like a blue color, I guess. And then this will be the graph of y equals secant of x. Okay, so here's what you do. Think of this as a camel. You are setting on top, camel's back, and then you're trying to kiss the asymptote. But not a very good kiss, just almost kissing it. Okay, then we do the kind of like the belly of the camel, like this, and that goes down like that. Again, it doesn't touch the asymptote, just gets infinitely close to it. Draw the shape like that, draw the shape like that, go downwards like this, and then upwards like that. Okay, so that's how that goes, is that would be your graph. And again, the way this works, it's real helpful to understand that if you were just a little bit bigger than, let's say, pi over 2, or yeah, let's say we're a little bit smaller. So if you did pi divided by 2, you know, you're going to get that value. So if we just closed in on that, and if we have a value of about 1.57 is what pi over 2 approximately is, if I was to go through and just do a simple calculation on this, if I did like 1 divided by the cosine, say, of 1.570001, okay, that's giving you a pretty big value, and that's what this is representing on that then, okay? So I'm basically taking a value that's real close to that, and then that would show you how that behaves around that asymptote then. So same idea on that too. So if we went a little bigger than that, okay, so if I went like 1 over the cosine of say 1.58, then you start seeing that you have negative numbers. So the idea is to the right of that, you're going to have negative numbers, and to the left of that, you're going to have positive numbers like the calculator shows. Okay, so that's how that works out. Okay, so here's a couple of things that you want to see on this. So basically the domain, if you were to go through and if you were to look at all these places where you're undefined, we're going to again look at a pattern, and usually it's pretty easy to predict what these patterns are. So what we're going to do is we're just going to write these out. So what you have is you have vertical asymptotes at these values. Pi over 2, for emphasis, I'm going to write that as 1 pi over 2, 3 pi over 2, and then you have negative 1 pi over 2, and negative 3 pi over 2, and so forth. So the pattern on this goes 5 pi over 2, 7 pi over 2, and so forth. And now if you look at the kind of numbers we're dealing with on this, just notice that we have 1, 3, 5, 7, negative 1, negative 3. Those are odd integers. And the other thing on this is, notice that everything has a pi over 2 in it. Okay, so when you construct and put together your formula, you're looking for that pattern. Okay, so what we would say on this for the domain is you would just write this as set of x such that x is not equal to, and then you would say k pi over 2. Then you would have to say k is an odd integer. And there's no symbol that I know for that, so you just write that out like that. K is an odd integer, okay? All right, now minimum value, if you look at your graph, there is no minimum value. There is no maximum value, because again, we're looking at the U shape there, okay? The range is numbers smaller than a y value of negative 1, and y value is bigger than positive 1. Okay, so you're really ranging on this like this. You're ranging from here below, and you're ranging from 1 and above on the y-axis like that. Okay, so when we write a range, we can write this one of two ways. We could write this as set of y such that y is less than or equal to negative 1, or y is greater than or equal to 1. Or if we wanted to, we could say interval notation. We could say negative infinity to negative 1, including the negative 1, and then 1 infinity like that. Okay, so that's how that would get put together. Okay, the period's 2 pi, same as the cosine. The amplitude, again, we don't have one because there's no max and there's no min. So if there's no max and there's no min, then you could not crunch out that formula, see? Okay. And then the equations of the vertical asymptotes, well, those come from where it's undefined, see? So what you say on that is you just say x equals k pi over 2, and then you have to state that k is an odd integer. Okay, so that's all the basic details of that graph then, okay? All right, now moving on to the next graph, we're going to go through and do a couple of graphs to kind of close off this lesson. And let me show you sort of how, excuse me, how these things work out. So what we're going to do on this one is we're going to really focus totally on graphing the sine. So our focus to begin with is going to be graphing y equals 2 sine of 2x plus pi over 3. Now, in order to figure out what the phase shift is, it looks like we have a phase shift. Then we have to factor that 2 out of this. So we're going to have y equals 2 cosecant, factor the 2 out, and then figure out what goes in that parenthesis. Now remember, to figure out what goes there, you're always just taking this divided by this. So you're doing pi over 2, or I'm sorry, pi over 3 divided by 2, and dividing by 2 is the same thing as taking half of something. Okay, so we're going to do that. So that's going to be pi over 6. Okay, and again, check it. 2 times x is 2x. 2 times pi over 6 is 2 pi over 6, but 2 pi over 6 reduces to pi over 3. Okay, now if we identify everything, well, the period comes from this number 2. So the period is 2 pi over 2. So that's pi. The amplitude, we don't have one. Now, the amplitude of the sine wave is going to be 2, so when we graph the sine wave, we're going to have to consider that. The phase shift is going to be, since we did this in a factored form, is going to be that number to the left. Okay, so we're going to write that as negative pi over 6 to the left, and we'll consider that. And then we need to be sure we divide the period by 4 to get the increment. Okay, so the increment is going to be the period, which is pi, and then we're going to divide that by 4. So we'll end up getting pi over 4, like that. Okay, now, as we go through and finish this up now and begin to get these things worked out, one of the things that we have to do on this is just start counting off by this increment then. So we're going to start at 0, and we're going to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and we'll count that out through a period. And of course, this reduces to pi over 2, and then of course this reduces to pi. And we could go out further if we want to. I'm going to keep going out a little bit. I go to 5 pi over 4, 6 pi over 4 is going to be 3 pi over 2, and so forth. Okay, so we're going to go ahead and begin to get this graph set up next then. Okay, so let's go ahead and go down to our graph, start getting this set up. Okay, so what we're going to have is we're going to have pi over 4, pi over 2, pi, 3 pi over 4, hold on, pi over 2, I think I got that backwards there. I'm going too fast here for myself. All right, let's get that corrected and go out like this. So we got pi over 2, then we have 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2 like this. Okay, then let's go ahead and go backwards. We may not go through all these points, but I want to kind of show you how we figure in the phase shift on this one. This one's going to be a little bit different in the way that we get this one put together because of where the phase shift falls on this increment. Okay, so take the time, and you can always remember pause this playback at any time you want to when you're working out your notes. Now, if you look at this problem, it doesn't have a vertical translation, but we probably need to go up maybe around 5 and maybe down to -5 because we do have an amplitude change on the sine wave. So we're going to do that then. Okay. Now, what I'm going to do is I'm going to go up here and I'm going to write down the sine wave. So when we're graphing this sine wave, we're going to be graphing y equals, and we'll go ahead and start by graphing out. Ultimately, we want to try to graph y equals 2 sine of 2 times x plus pi over 6. So that's ultimately what we're trying to go through and do. Get out of the way, calculator. Okay, so I think that's what we have. Yeah, okay, so we're going to go ahead and graph that in the factored form and everything. Okay, now one of the problems on this is, see this pi over 4 right here, this thing is really 45 degrees. pi over 6 is really 30 degrees. So this phase shift does not fall directly on those increments. So what we have to do is we have to kind of subdivide the interval. And we have to go like this. We actually, 30, we could break it up into 15. So if you did 45 divided by 3, you'd get 15. So what I'm going to do is I'm going to put 15 there and I'm going to put 30 there. Now I'm going to do, just kind of break this down and sort of color code this so you can see this okay as we get this done. Okay, so let's just kind of subdivide the intervals. And then I'm going to go like with a green color because, again, I want to kind of color code this. This is going to be where the 30-degree increments are going to fall, so we're going to be working with this increment like this. You have to subdivide on these things, and that's just kind of part of what you have to do is estimate where it is, but we can get a lot of accuracy on this one when we do this then. Okay, so what we want to do with this then, and we can graph this in one stage now. So we're going to start at this phase shift. So we're going to go 30 degrees really to the left. Okay, so the first thing we want to do is I'm just going to very, very lightly graph out a sine wave. Okay, now, and then you can figure in the phase shift if you want to. So we know a sine wave basically would cycle through these points. Now we've already considered the period change. Okay, like this. So let's just get a few points. This point right here is going to phase shift to this point. So that new point is going to go there, and that's now gone. Okay, this point is going to phase shift, and again, what we're doing is going 30 degrees over, like this. So you're going to end up phase shifting. That would be 15 degrees that way. Then you'd have 30 degrees like that. So that point right there would actually go to there. Okay, and then we can kind of just sort of dash these in as we go. This point here would phase shift here. Okay, so we'd have that. Okay, again, keep in mind we're going 2 notches. Okay, and that would take care of that point now. So that one's, oh, come on, did I do that wrong? Okay, I've got that one. Now that point right there should have phase shifted there. That point should have phase shifted there. I think what I didn't do is connect the dots right on that. Okay, so let's get that thing off of there. Like that. So see this point right here. Yeah, this one right here would phase shift to this point right here. So that means that what we would do is we'd have to connect the dots like this. So that would go like that. Okay, and then so forth. Now you'll kind of notice on this that every 3 notches, 1, 2, 3, is where we're going to end up having these things. So you kind of look at this on this side, these things are going to correspond to where that red dot is. So this next point is going to phase shift to here. So that takes care of that. This one phase shifts here. And then once you get the pattern on this, you can tell where the rest of them go. So go 1, 2, 3 notches. This point's going to go there. 1, 2, 3 notches, that point goes there. And 1, 2, let's see, 1, 2, 3, this goes here. And so forth. And I'll just kind of stop at that point. This one goes 1, 2, 3 to there. And then 1, 2, 3 to here. 1, 2, 3 there. Come on, right there actually. Okay, then this would go 1, 2, 3 there. Kind of on this side, we're lining up with the green dots. And then that would go like that. Okay, now what we need to do is we need to figure in the amplitude. Now you could have done that in one stage on the problem if you wanted to. And it doesn't matter. So what I'm going to do is I'll take a secant graph and now I'll figure in this amplitude change. So all I'm going to do on this is just move this down to -2. That's going to stay the same. That's going to move up to 2. This will stay the same. That'll go to -2. That'll be the same. This point right here will go to 2. So now we can kind of begin to go through and cycle through these. Now remember, you're trying to line up with the green notches here. like this. Okay, and let's see, this one will stay where it is. This one will go down to -2. That one stays the same. That one goes up to 2. And this one will basically stay the same. Okay, like that. All right, so what we need to have next is we need to go ahead and identify the asymptotes. Now, the asymptotes always occur where these midpoints are. So one of the things you're going to have on this is you're going to have midpoint here, 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 there, there. Those are your midpoints, like that. So we're just going to do those, and then we'll cycle through maybe a couple of periods on this. Okay, so I'm going to go ahead and just do this in red again. I'll just go back and do that. So I'm going to draw a vertical asymptote there, like this. Okay, I'll have a vertical asymptote here. Then I'll have another vertical asymptote here. Then I'm ready to sketch in, like this. So the midpoints are where your vertical asymptotes always are. Okay, so we got the asymptotes identified. Now the rest of it is just sketching in the wave then. Okay, so I'll go ahead and take, like, say, a blue color, and then this will be the graph. So we want to go like that, approaching the asymptotes. Go like this, like this, and like this, and like this. Okay, so that actually will take you through a little bit more than one period. So from there to there would be one period, and from there to there would be one period, like that. Okay. All right, now if you want to find the equations of the asymptotes, this is where this can get a little challenging. And one of the things you can do on this is, you know, if you go back and if you look at, sometimes it's hard to find patterns on this, but if you go back and look at what we just got through graphing, we just got through graphing y equals 2 cosecant, and in a factored form we were working with x, come on, stop that. I can't talk and write at the same time sometimes. So let's see, what we had was 2 times x plus pi over 6. Okay, now what we call the argument is whatever is in these parentheses that you're taking the cosecant of. So what you can do is you can set the argument equal to an angle where the sine's 0. Okay, well, on a unit circle, the sine is the y value, so the sine is 0 at 0 radians. So what we're going to do to find the first asymptote is we just take 2 times x plus pi over 6, and we set that equal to 0. Then we can solve that equation, see, okay? And then that'll give us a place where it's undefined. Well, I could divide by 2, okay, and then that would give x plus pi over 6 equals 0. So that would be x equals negative pi over 6. So that would be one place where it's undefined, okay? Now, what you can do on this is you can find the next asymptote if you want to. One of the ways that you find the next asymptote is you add half the period, okay? Because at halfway in the period, so if you look at a period on this, like this is pi over 6, that's your first asymptote, then the end of the period's here, well, halfway in between that period is the next asymptote. So what you can do is you can take negative pi over 6 plus 1/2 of the period, and then that'll give the next asymptote. Okay, well, the period on this, when we crunched out the period on this, we got pi over 2, I believe. Yeah, we got pi, sorry. So what we need to do is just take half of pi. Okay, well, we'd have to get a common denominator by multiplying that by 3 over 3. So we'd have negative pi over 6 plus 3 pi over 6. So that would be 2 pi over 6. So that would be pi over 3. Okay, but I'm going to go ahead and write this kind of like that with a common denominator. Okay, Then what you'd basically have here, if you went through and did this, is you start looking at a pattern now. So if you took the second one, 2 pi over 6, and again you added half the period to that, which is pi, that would be 2 pi over 6 plus 3 pi over 6. So that would take you to 5 pi over 6. So sometimes it's really hard to see patterns on this. This is, you have an asymptote really at negative pi over 6. Then you have one at 2 pi over 6. Then you have one at 5 pi over 6. Now you can see the pattern on this. These things are basically, the numerators are going up by 3. But it's kind of hard to write the equation of the asymptote, so I always recommend that you use this formula. So when you write the equation of the asymptote, you say x equals, and you just pick an asymptote. I prefer that you take the first positive exponent. So it's kind of like what you do is you say x equals first positive vertical asymptote plus 1/2 the period times k, where k is an integer. Okay, and this will always work. So we're going to say pi over 3 is this first asymptote. Then we're going to say plus 1/2 the period. So the period's pi, so we say 1/2 pi times k, and then we say k is an integer. And that will always work out. That will give you a formula for that. If you plugged it in, I mean, it'll work out. If k is 1, that's really what we just did here. If k is 1, we did this calculation down here. So that's the vertical asymptote. So one thing that's kind of helpful when you get these problems that are a little bit more challenging to find patterns on, I recommend that you do this. Okay, just use that period. And the reason that we say half a period is because if you look at this, basically from here to here is a period. Notice that you have an asymptote halfway in the middle of that period. So here's an asymptote. Half of the period gets the next one. Then you get another one like that. So every time half a period goes by, you're going to get another vertical asymptote. Okay, so let's do this one last problem on this page to kind of close this up here. So what we'll be looking at on this one, the first thing we want to do is we want to write this in a factored form. So we're going to have y equals 1/2 secant. Again, we're going to factor a 2/3 out of that. So when we factor a 2/3 out, we need to figure out what goes there. Okay, and what you always do is you take this and you divide it by what you're factoring out. So that's really pi over 6 times 3/2. Okay, that reduces down to a half. So that's going to be pi over 4. So you may end up with one of these things where you're on kind of a funny location on these things then. Okay, so let's see, the period is 2 pi divided by the coefficient of x. So that's going to be 2 pi times 3 over 2. That's going to cross out, so that's going to leave a period of 3 pi like that then. Okay, all right, amplitude, we don't have one. Now we do on the cosine wave. Phase shift is going to be this number. So that's going to be pi over 4 to the right. Okay, then we're going to graph basically this function right here first. So we're going to take the period 3 pi and divide that by 4. So our increment of our x-axis is going to go by 3 pi over 4. So we're just going to start this out like this and kind of get this put together. So we're going to start with 0, then we're going to go 3 pi over 4, 6 pi over 4, 9 pi over 4, and 12 pi over 4, 15 pi over 4. I think that'll be good enough to go out that far. We do have to figure in a phase shift on this now. And then what we'll have is this will reduce down to 3 pi over 2. This will reduce down to 3 pi. And then that'll take us through a cycle. So if you look at 1, 2, 3, 4, 5 key points, takes us through a cycle. That right there, since the period's 3 pi, will give you one cycle of the wave. Okay, so now what we're going to do is we're going to go ahead and get our axis put together. So we need to go ahead and get that done. So kind of take the increments that we worked out here and do this. So let's go start with 3 pi over 4 and then 3 pi over 2. Okay, then 9 pi over 4, 3 pi, and we'll go out to 15 pi over 4, and we'll do this in both directions. So go ahead and do that. Okay, it looked like we had an amplitude of 1/2 on this, so let's go up maybe, I don't think we have a vertical translation, so let's go to 1 and 2 like that. That way we'll have enough room to sketch in the wave that we have. Okay, now I'm going to write down what we're getting ready to graph. So we're going to go ahead and graph 1/2 cosine, and the factored form on that was, let's see, 2/3 x minus pi over 4. Now pi over 4 on this you're going to find is going to be a phase shift to the right. So when we do this phase shift, we're not going to fall on the increment. So if we're going pi over 4, we have to subdivide this up like this. We have to subdivide this into 3 parts. So again, you got to be kind of careful about how you do this. So this would be pi over 4. So I'm going to just go over about 1/3 of the way to subdivide this increment like that. Okay, so I'm going to go like that. I'm going to try to do a little bit better job on this like that. Then I'm going to go ahead and do green because that will help us keep track of this. So what we have basically is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and so forth. So we have to subdivide this out so that we can get the phase shift accurately located then. So we need to go ahead and do that. Okay, like this. Okay. So now when we do this, we're going to go ahead. We're pretty well ready now to graph everything. So I'm going to go ahead and just keep this in a red color. Now remember the cosine starts high. Okay, this is where your cosine wave starts. However, we're going to go to the right pi over 4. So this point right here needs to go to this. It needs to line up with this y value here. However, because of the amplitude on that cosine, then that is going to be a value right there. Okay. Now, we don't have a vertical translation, so that means the next point is going to go down here. Then the next point is going to go down 1/2 there. Then there, and so forth, like that. So what we're doing is we're making sure these points line up with that phase shifted value pi over 4, like this, and then we can put this together. Okay, so we're just going to keep going like this. It's just basically going 1, 2, 3. We subdivided this into 3 increments, so we're going to go like this. Then we're ready to get our sketch of our graph. So see, with a little practice, you can do this all in one step in your head. Now what I'm going to do is locate all of the asymptotes. The asymptotes always occur at the midpoint. See, if we had a vertical translation, like if we moved this up 1, it wouldn't change where those midpoints are. So you're going to end up having asymptotes always where those midpoints are. Okay? So when we do this, we're going to go ahead and do a sketch of this now. So we're going to go ahead and locate our vertical asymptotes. You want to put those in. And then we'll be ready to sketch, find the asymptotes, and we're done. Now I went ahead and did a couple of more difficult problems. We hadn't done many problems yet where the phase shift ended up being not on one of the values of the increments of the x-axis, so I did want to go ahead and use this section to teach that a little bit. They won't always be that complicated if you don't have to subdivide those increments, and it doesn't matter. It makes it a little bit easier. So now what we'll do is we'll go through and we'll sketch this out like this. And then we'll have a nice sketch through about 2 periods. So up U shape, down U shape defines 2 periods. Okay, if you wanted to do that little piece right there, you could do that like that. Okay, now the formula, it's just as easy to do a formula for an asymptote on this. Now, the formula really is x equals, I like to say, first positive vertical asymptote plus 1/2 the period times k, with k being an integer. Okay, so that's how it works. Well, the first asymptote was pi over 4. That occurred where the phase shift was. So what we would say is we would just say x equals pi over 4 plus 1/2 of the period. Now the period on this we got was 3 pi. So it's going to be 1/2 times 3 pi, where k is an integer. Okay, so you could write that if you want to as 3 pi over 2. The best way to write this would be x equals pi over 4 plus 3 pi over 2, with k being an integer, like that, and that always works. And again, the reason that you do half the period is because if you look at the period here, and I'm just going to take my highlighter and kind of box in a period here. See, the period has 2 asymptotes. One of the asymptotes is halfway in between. So that's why we do that, see, is because of that. God, what a mess here that I'm making with that. Okay, so that would be the idea. Now, the other thing you can do on this, too, is you can take the argument. Now, the argument is this thing right here, 2/3 x minus pi over 4. So you could actually take on this, that argument, and set it to a place where the cosine is 0. So let me show you how you would get that pi over 4. So if you go up to this, the period here, or the argument is this piece here, which is 2/3 x minus pi over 4. Now you're going to set that equal to a place where the cosine is 0. Well, the cosine is 0. One place it's equal to 0 is at pi over 2. So if you set it equal to pi over 2, then you would get where that asymptote goes. Or you would at least get one of the asymptotes if you did that then. So you could multiply both sides by 3 over 1 to get the fraction, not 3 over 1. You'd have to multiply it by a common denominator of all these, actually. So let's forget that. That's not going to do us any good. Basically, if you look at 3, 4, and 2, the common denominator of that's 12. So if we actually multiplied both sides of this by, or actually we could just multiply by 6 to get rid of that, or maybe we'll go through and do it this way. You guys might do better if you just distribute that and get 2/3 x minus 2 pi over 12 equals pi over 2. Okay, now if you want to reduce this fraction down to 1/6, you would end up having 2/3 x minus pi over 6 equals pi over 2. Then if you multiplied both sides of this equation by 6 to get rid of all the fractions, you would get, this would be 12/3 x minus 6 pi over 6 equals 6 pi over 2. So that would be 4x minus pi equals 3 pi. Add pi to both sides, then you would end up having an asymptote. Yeah, I just kind of caught a mistake here that I was looking at, and I'll explain where that mistake was. So if you do this, you would have 4x equals 4 pi. Divide by 4, you would have x equals pi. Okay, so my apologies. This right here should be pi. Notice your first asymptotes right here. This is really, this went 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So that's where your first asymptote is. So I need to correct that then. And just write that as pi. And then that'll close off the problem. Then I do want to finish up just by showing you how you could check and tell that you're right on these things, because I think that's always a fairly important thing to do, because these problems can get fairly complicated. So that would be what your equation of your vertical asymptotes is then, okay? Now, just I'm going to kind of move my calculator. Now, if we wanted to check this, like for instance, we have to finish this up, we just got through graphing really y equals 1/2 the secant, and you can go back to the very original 2/3 x, what was it? It was 2/3 x minus pi over 6. Now, after you go through this, it's easy to be a little bit not very confident in what you've done here. So you can take any point on here, any of these key points that are on here, like this one's pi over 4. And we would like to see if we plugged in pi over 4, which is this point, do we get a y value of 1/2? So let's work that out and see what we get. So we get y equals 1/2 secant 2/3 times pi over 4 minus pi over 6. And let me show you what happens. It'll end up going to the unit circle. So this is going to be secant of, see, that's 1/2. So that's going to be pi over 6, like that, minus pi over 6. This is equal to 1/2 the secant of 0. And on a unit circle, the secant of 0 is 1. So 1/2 times 1 is 1. That checks out. So the thing is, you could check any of these key points. And the key points on these things, let me just highlight what these key points would be. One of them would be here at pi over 4. That would be pi. This one, you would have a key point, that one and that one. So all of those things, if plugged in, would check out. Okay, that'll be the end of that. Those last two examples can be a little tricky, but the whole key is if you can graph the sine and cosine, then you can graph the secant and cosecant. Okay, so I hope that helps. You may have to work a little bit on the last two. A little practice, you shouldn't have any problem getting those put together. All right, thanks for watching.